The Japan Testing Center for Construction Materials, JTCCM, is a third-party organization which has been in operation for more than 50 years in Japan, specializing in quality performance testing, ministerial approvals, certification under JIS and JAS, and approval of building materials as specified under the aforementioned provisions of building standard law. This kind of testing must be done a short distance from the construction site. Now, let's take a look at our construction materials testing facilities, where the needs of our customers are satisfied. JTCCM is now recognized as an outstanding comprehensive certification authority that contributes to the advancement of quality in housing and construction. Construction materials, components, equipment, and machinery testing. ISO, JIS Mark, and JAS Mark certification and performance evaluation. Support for social infrastructure maintenance, and more. These activities contribute to the advancement of the construction and building materials industries and help improve residential housing and social capital in Japan. The Central Test Laboratory is located in Soka City in Saitama Prefecture, while additional facilities are situated to meet customer needs throughout Japan. One of these, the Construction Materials Test Laboratory, serves the entire Kanto region of Japan. In various laboratories, tests are conducted to evaluate whether or not concrete, rebar, and other civil engineering materials satisfy the required quality and performance controls by meeting established standards and specifications. Construction Materials Test Laboratory's Senior Managing Director Takatsugu Mano talks about the laboratory's special characteristics.
鋼材料試験所では鋼材システムというシステムを導入し、4試験室間のネットワークを図り、試験の受付から試験報告書の発行まで依頼者の皆様に迅速に対応できるようなシステムで対応しています。今後はこの鋼材システムと計測システムをより充実させ、さらなるサービス向上に努めたいと考えています。
The main Construction Materials Test Laboratory conducts many operations such as testing concrete and metallic materials. Each laboratory is a registered accredited body under the Japan National Laboratory Accreditation, JNLA, under JIS law. It also has a quality management system complying with JIS Q 17025. The Construction Materials Test Laboratories are also registered as accredited service providers under the JNLA and the JCSS, Japan Calibration Service System, and is a certified Tokyo Metropolitan Class A, Class B testing organization. To order a test, first call the lab nearest you. Test specimens can be brought directly to our office along with the order form, or you may ship them to the lab via package delivery service. After confirming receipt of payment, testing is done and a report is generated. Test result reports are delivered by postal mail. In concrete tests, concrete and mortar specimens collected at construction sites are put through a series of strength tests and other tests. Here we see a compressive strength test underway. The specimens we receive from customers, according to regulations, are cured in air or water until they are ready to be tested. For compressive strength tests on concrete, at the Musashi Fuchu Test Laboratory, the maximum load is up to 3,000 kilonewtons, while the other test laboratories can provide a maximum test load of up to 2,000 kilonewtons. When pressure is applied at a given speed, at some point the test specimen breaks. Normally, 3 specimens are tested in this way, and the average is taken. Customers standing by to oversee the process can watch the test results displayed on a monitor in real time. At the Musashi Fuchu Test Laboratory, it is also possible to conduct compressive strength testing on ultra-high strength concrete at the level of 150 newtons per square millimeter. Concrete tests are available at each test laboratory as follows. In metallic materials tests, steel test pieces collected at construction sites are put through a series of strength tests and other tests. Here we see a tensile test and a bend test underway. The Funabashi Test Laboratory is equipped with the Kanto region's largest 2,000 kilonewton all-purpose testing machines for long test pieces. This testing equipment can handle tensile testing on test pieces up to 3 meters long. Also, since a lot of vibration is generated during testing, the device is fitted with a shock-absorbing foundation underneath. This design contributes to neighborly goodwill. This all-purpose testing machine is used to perform tensile strength tests on rebar base materials and all kinds of couplers on fittings. Testing includes measurement of breaking points, tensile strength, stretching, and the like. A 50 milliliter diameter steel bar breaks when subject to a load of 1,000 to 1,500 kilonewtons. As you can see, there was also an elongation with the fracture. In the bend test, a maximum of 300 kilonewtons of force can be provided at all test laboratories. After the test, a metal brush is used to remove any particles, and the steel component is carefully checked for cracks. Metallic materials tests are available at each test laboratory as follows. In earthquake resistance diagnostics, various testing procedures are carried out on concrete core samples collected from existing structures. Here you can observe testing of the static modulus of elasticity, carbonation, and chloride ion content. The specimens are cut to the appropriate size for testing, and the cut surfaces are polished smooth. Next, strain gauges are attached to the test specimen and connected to a special instrument. This measures the distortion of the test sample under compression and determines its static modulus of elasticity. In the carbonation test, the test specimen is first split in half and just one side is sprayed with a phenol-phthalene solution. The non-carbonation section shows a purplish red, while the carbonation section shows no coloration. The distance from the surface of the test specimen to the carbonation section is measured, and this data is used to estimate the deterioration level of the concrete. The Yokohama Test Laboratory has an excellent track record for concrete core compressive strength tests, carbonation tests, and other earthquake resistance diagnostics testing. In order to measure the chloride ion content, the test specimen is first crushed and ground up. The powdered sample is mixed with concentration-adjusted nitric acid and boiled. After cooling to a fixed temperature, the aspiration-extracted solution is measured with instrumentation that determines the chloride ion content. Earthquake resistance diagnostics tests are available at each test laboratory as follows. In residential housing foundation concrete tests, fresh concrete brought to residential housing construction sites is subject to the slump test and air content test. Here you can see how these processes are done. As soon as an agitator truck arrives on a residential housing construction site, the paperwork is checked and the fresh concrete is collected. First, the temperature of the fresh concrete is checked, and the chloride ion content is measured with an accurately calibrated chloride content measuring instrument. Next is the slump test. To determine the air content, a special instrument called an air meter is used. Finally, we make the test specimens for conducting compressive strength tests at the laboratory using special molds, and the process is complete. Because the qualities of fresh concrete will change from moment to moment, this testing is a kind of race with time. For easy checking of the compressive strength of residential housing foundation concrete, the Japan Testing Center for Construction Materials has developed a deliverable compressive strength test set. The set includes an application form, invoice, and detailed manual, all in an easy-to-use package, so please try it. Residential housing foundation concrete tests are available at each test laboratory as follows. For civil engineering materials tests, we conduct all manner of testing on road pavement asphalt mixtures. Here you can observe one of these. From the asphalt mixture, just the asphalt portion is extracted using an automatic asphalt extraction apparatus. With the asphalt extracted, the test sample is the remaining aggregate only, and by shaking and separating these, we can determine the component ratio according to the size of the aggregate. For the sub-base coarse material to be used in road pavement construction, we offer a variety of tests, including the sieve analysis of aggregates test, density, the water absorption test, etc. Here you can observe a soil compacting test. The sub-base coarse material is put into a container and well compacted. Then, in order to get the proper moisture content, it is immersed in water for 4 days. After that, the container is removed from the water and placed in a penetration apparatus that measures the degree of water penetration. The Urawa Test Laboratory is equipped with a large-scale sub-base coarse materials automatic sorting apparatus and conducts a wide range of civil engineering materials testing, including for ground improvement materials, sub-base coarse materials, improvement soil, sub-base coarse soil, aggregates for road construction, etc. Civil engineering materials tests are available at each test laboratory as follows. Other testing services are available at each test laboratory as follows. At the Quality Control Test Laboratory, as an MRA-supported official JCSS certification authorizer, we also conduct unconfined testing apparatus and load cell calibration business. Furthermore, we use a quality management system to provide inspection of concrete grinders and also provide calibration services for chloride concentration measuring instruments.
私ども工事材料試験所ではさまざまな試験設備を備えて多種多様な試験を実施しています。また職員の技術力の向上に努めることはもちろん、各種の計測システムを導入し試験精度の向上に努めています。高い技術力と確かな技術、この2つを基本とし、皆様からのご依頼にお応えしたいと考えています。
A quick response after just one telephone call. The Japan Testing Center for Construction Materials Test Laboratory is a business partner for all. Please use it.